What is varnish? Well, ASTM D7843 defines varnish as a thin, hard, lustrous, oil-insoluble compound, one which is composed primarily of organic residue. Essentially, varnish is a lubricant breakdown product which has some propensity to become insoluble, and when it does, it can lead to a variety of operational issues, particularly in critical rotating equipment like gas turbines and compressors. Now we have some photos on the right-hand side of the slide, and you can see that varnish takes on a variety of different forms. It can be a deposit as shown, it can be a sludge as shown, or it can also be a deposit or an organic residue that's captured on a lab filter patch. Now, regardless of the form that varnish takes, again, it has a detrimental impact to the performance and reliability of critical equipment, and nowhere more so than in gas turbine applications, where varnish can cause valves to stick, which can lead to costly fail-to-start conditions. Now, you may have noticed that D7843 definition of varnish defined it as being insoluble. So let's hone in on that in a little bit more detail and discuss the discrepancy or the differences between something that is soluble versus something that is insoluble. So in this everyday example, I'm going to allude to salt in your salt shaker at home, because this is something that everyone is familiar with, and we're going to build up our understanding of solubility chemistry with this common everyday example. So in the salt shaker, we know that the sodium chloride that's present, your table salt, is in the solid state. Now, if we were to add this sodium chloride to a turbine oil, for instance, it would remain insoluble, so it would remain in that solid state. But we also know that if you add that sodium chloride to a different fluid, water for instance, well, it will dissolve quite easily. And a common example, of course, is sodium chloride in seawater. Now, whether or not this salt is soluble or insoluble has important implications for how you might want to remove it from that solid. In the instance where salt is insoluble in the turbine oil, you can use common filtration, which relies on sieve-type filtration. You're literally just pulling out the solid particle from the fluid. But clearly that is not going to work in the case of seawater. If you want to remove salt from water, you're going to have to use a more advanced technology, something like distillation, reverse osmosis, or even ion exchange. The fact that sieve-type filters don't eliminate varnish issues in turbine oils proves that varnish also exists in a soluble form that the current D7843 definition overlooks. Like salt, the removal of this soluble varnish, therefore, requires the use of an appropriate ion exchange filter, like ICB.